Hello, everybody. Yeah, for those who don't know me, I'm Samer. I'm working as a software engineer in the Settlr team at FlixBus. Today, I will walk you through an introduction to the event sourcing, how we implemented it, and why we implemented it in the project, in the Settlr project, and what the costs it came up with. So first, Settlr is built using Java with Spring Boot. We use also Groovy and Angular and TypeScript for front end. We build over Docker with Kubernetes. We use also MySQL and Presto for persisting. Settlr consists of three main components. They collaborate together to achieve the task of Settlr of generating financial settlement for our mobility partners. The main component is Settlr. It is a data management where the users enter the data and generate the settlements out of it. Our application is an internal application. Our users are internal users, and we have limited number of users. When the Settlr project came to life, the business stakeholders put some quality goals. One of the main quality goals was the auditability. Auditability means that the results of our application should pass the financial audit. This means when the tax authority control come to the company to do some checks, we have to answer all their questions. The main three questions we had to answer, or our application has to answer, is what happened and when, who did it, and why and how did we get the resulted values. While the first two questions apparently are achievable and can be implemented by classical logging, the third one, not really. It's a little bit tricky. So let's see what does this mean. So let's take that we have a settlement for January generated at the 1st of January, and the auditor said, okay, guys, how did you get this number B? So we should track the formulas, and we have some parameters in the formula. These parameters had values at that time. We should go back to the state of our models at the point of time where we generated the settlement. So the auditor can here see all values, scan all the whole models at that point of time. Then maybe he can, sorry for this inconvenience. We can fix it later. Okay, yeah. So the auditor can go further and ask, so how did you get this 6 number? How this developed to be 6? So we need to go back in time, but not back to break something. Yeah. So let's put this here. So we go back in time and check the history points. We see like how this developed from 4 to 6. What's the method? Then the auditor can ask like, okay, guys, show me when it was 4 here. Show me the context of your values. So we need to show the auditor what were the values of everything maybe, and he can have the ability to scan everything. So apparently, the classical logging cannot achieve this. Here comes the event sourcing. Who of you is familiar with event sourcing? Okay, I can go home, actually. Yeah, so like 50%, cool. This is helpful. To introduce event sourcing, let's recap first with the CRUD model. In the CRUD model, the create, read, update, delete. In the CRUD model, we persist the state. So every time we have a new state, we overwrite the older state. So we have no idea, or we don't store anything about the old state. We have no idea how the new state developed, what's the behavior of it. So for example, if we have the model called fee, it holds information about different fees with their amounts. And we have an instance with the number 15. We want to increase this 15 by 2. In CRUD model, we just simply persist it with the number 17. So we have no idea it was 15 before, and we have no idea how it increased and how we did the increment. In the event sourcing, on the other hand, we don't we don't store the state as we do in the CRUD, but for each change we do, we publish an atomic immutable event, and for the sequence of changes, we have sequence of events. And every time we need to get the state and generate it, we just replay all events till up to the current state. Yeah. I'm happy that I'm not a wheel here. So, okay. And of course, the stream of events, we store it in something called event store. Let's take an example. So, for creating a new event, for creating a new model for toll fee with value 15, we just create a new model. We call it fee added event, and usually the event should be named with verb. He's not part of the presentation, by the way. So exactly, this is how event sourcing whips the CRUD model. So it beat it and just thank you very much. Sure. So event sourcing wins. Cool. So as we said, we create a new event. We call it with some verb in the past participle form, added, increased, committed a suicide, whatever. And we store it in the event store. And now when we replay the events, we will have in our state, we will have some model with the value 15. We want to increase this 15 by 2. We create another event. We call it fee increase event or whatever, and it has the offset and a reference to our model. And we store it in the event store in the sequence. Then we replay the events again, and we get there the same fee, but with the number 17. So at the end we had a full history of the context, how our state was changing over the lifetime of the application. So this comes as the main benefit of event sourcing. Event sourcing also comes with some benefit of possibility for generating statistics. Let's say, for example, we can query the event store to generate information about like how frequent the users interacted with some feature on Friday afternoon, like today, now. Or also we get testing benefits. Because we have the events stored, we can use them as use cases for our end-to-end testing, for example. Of course, nothing comes for free. We have drawbacks. One of the main drawbacks of event sourcing is query performance, because we have to replay all events from the beginning till the end to generate the current state. This means the longer the event stream is and the bigger the events are, the time to generate this state is longer and will cause bad performance. Usually this is solved. We have two solutions for this. The first solution is to create a snapshot at one specific point of time. And this snapshot stores the state up to this point and summarizes all events that is older than this, so that the next time every time we want to replay the events and generate the current state, we just start from here and not from the very beginning of the time. The other solution is to store the current state in the database. So every time we publish an event, we receive the event and we modify our local representation of the state accordingly. Sorry. Okay, the other major drawback is maintaining the history. We will talk about it later. At this point, the team, like 2 years ago, started to search for a framework to implement the event sourcing. For Java, we didn't have a lot of options, only a few at that point of time. But one of the most suitable frameworks our team found was called Axon framework. It is an open source CQRS framework for Java. So it has event sourcing in it, of course, but it is CQRS. Who's familiar with CQRS? I should go home. Okay. Yeah. Okay, cool, but it's useful to speak maybe. So what is CQRS? If we talk in the domain-driven design terminology, usually the traditional applications have one domain model for one information. In the CQRS, on the other hand, we separate the read model from the write model. So we will have a command model to receive the commands and write the information only. On the other hand, we will have the read model, which is query model. You just get the queries and read the information, writes nothing. Usually the command model in CQRS is held and implemented as an aggregate. Aggregate is an entity or group of entities that are held together in a consistent way so that one transaction has the only scope of one aggregate, no more. The read and write in CQRS communicate through events. So let's see how a CQRS application with event sourcing can look like. So in the CQR applications, we will have a command handler to handle the command and read the information, and another for handling the read, handling the queries. So we call it event handler. Each of them have their own representation, local representation of the state, mostly, in which the command model and the query models are stored on each side. And they communicate, as we said, through events, through the event store. So let's take an example of the workflow, sorry. Something is not apparent, whatever. So the command the command handlers receive the command and directly returns a result like, hey, all's good, I got the answer, it's okay. Then it starts, I don't know if you can see, I don't know if there's some bug here. It creates a transaction. In this transaction, if you can see, it blocks the event store, or actually it blocks the events that are responsible of editing this or changing this aggregate, and then start validating the command against the command model. Usually the command model is always up to date with the event store, usually. If it fails the validation, it returns again a result, but later. So either per email or per push notification or whatever. But if it succeeded, it sends, it publishes an event, it's stored in the event store. And on the other hand, the command handler receives the event and updates its query model. So the CQRS comes with the benefit of scalability, because in the enterprise softwares, usually we have the read more than the write. So in this case, we are able, because the read and write models are segregated, we can scale the read as much as we want. We can fire up like 50 or 100 instances of it. And this brings us also performance benefits, and also because of the quick result response of the command handler, we have also a good performance at the right side. Of course, the drawbacks is the complexity, because we have to maintain two models, right, at the same time for the same information. This is one of the major drawbacks of CQRS. And the eventual consistency. I don't know if it's drawback. This is maybe the real life consistency, but this is different from the full consistency in the CRUD. This is because the command model and the query model are consistent, but with a difference in time. So this here will have the up-to-date information, and the other one will get this information later, maybe in 1 millisecond or 2 seconds or 2 years, who knows? But at the end, there will be consistent. This is why we call it eventual consistency. So the team sat and put the event sourcing and CQRS pros and cons together, and thought that because we are internal application, limited number of users, the scalability and performance for sure is still important for us, but it has a little bit lower priority than the other factors. So we decided to give up the idea of CQRS. So we just want event sourcing, but we are still using Accent framework, CQRS framework. So we ended up with an implementation with a special design. So this is our application. We still have command handler and event handler, like in CQRS, but these both handlers are residing in the same application and the same deployment. They are sharing the same model. So we are not segregating the models. We have the command and the query model as one model. It is also the aggregate. It's even we use it as a JPA entity. The both command handler and event handler, so the read and the write, are happening in the same transaction. And our event store is stored in the same relational database where our models are stored. Well, this means nothing, because we could have stored it in any other independent store. So it was just a matter of choice. So at the end, we achieved less complexity. So we avoided the CQRS complexity by maintaining two models. We maintained full consistency. It's like the CRUD. So actually, we cannot scale. We have everything in the same transaction and the same model. But we achieved the auditability at the end. All that comes with costs. So as we said before, the event sourcing comes with the maintaining history cost. What does this mean? So, because the software application's changing, it's the nature of it, the definition of our events change through the time. So this makes the current state of our application with the latest version of the events incompatible with the old events. So, right, so the application is going and developing and having new versions, while the old events are, because they are immutable, they are not changing. So here comes the upcasting. The upcasting is transforming the event from the original structure to its new structure. Let's take an example. So let's say we have that event, fee added event, and we held in it currently in the version 2, in the current state, gross amount and tax rate of the fee. While in the old version of the same event, version 1, we had held gross amount with net amount, no information about tax rate. So our application needs to read these information when we replay the event store. The solution to do it is to write an upcaster. So in upcaster, you just do some processes to cast this information or using other sources to generate the same structure that you have that suits your application and make it running as it is expected. So unfortunately, almost every change we do on our aggregates, on our models, we have to write an upcaster for it, or more or less. So it is very painful. It's time-consuming. Also, some upcasters are very complex, so sometimes the proper solution is to stop using this event, deprecating it, creating new events, and so on, or maybe do some hacky solution by querying the current state inside the event, inside the upcaster, sorry, which should not happen. This is a little bit hacky. So this is one of the challenges. Another challenge is that we have to keep all the changes inside our events. So we cannot do something without the events, or we can do, and the life is beautiful, till we try to replay the events again. So let's take an example. If someone comes and say like, I just need to object to instances here, I don't have to fire an event for it. We just use SQL migration for it at this point, right? And someone comes later and just replays the events. Some events that are generated after this point of time will maybe have reference to these models, which are existing only in the application or representation of the state, but not in the event stream. This will cause the replaying of event to break. So another problem, another challenge we are facing is that we are depending on a framework, which is a CQRS framework, while we decided just to go for event sourcing. So the future of that framework maybe is going in different direction than our decision and our design. So for example, lately, or we are using in our application some repository from the Axon framework. It's called Hybrid JPA repository. It helps us to do all the transaction of read and write and firing the events in one transaction. Simply in the version 3 of Axon, they decided to drop it off because it's not very CQRS for them, because they are CQRS framework and going in that direction. Now we cannot upgrade to version 3. We can maybe upgrade, but we need to do some workaround. And maybe the version 4, who knows what will be, and maybe we'll not be able to upgrade there also. This is one of the challenges we are facing. Another one, it's like more design problem. because we are having the model, the write and read model in the same model, every time we do changes on the view, we extend the view, we are extending our aggregates. We are extending also the command model. So we are corrupting the command model with it. So it's some dirty solution. So the team is trying now to digest our design, trying to ask the question about the event sourcing. Should we continue with the event sourcing or shouldn't we? If we were able to go back in time and choose again, should we have chosen to go with event sourcing but with proper CQRS implementation, or maybe another framework or event sourcing, or maybe another solution, no event sourcing. We just try to convince our business stakeholders, hey guys, I mean, could you please drop off this question of why? There's too much questions. Can you just compensate it? Because it's very costly for us to implement the event sourcing with this solution. I don't know. We are afraid that we are too late. Actually, we have challenges. We have to face them. And we are doing that. That's all. Thank you very much.